Welcome to the inaugural episode of the E3 podcast, Energy and Efficiency with Emily. This episode, we're going to highlight a recent discussion by the BS and Beer crowd on exterior insulation. To join us today and lead the recap, we have Mike Maines from Michael Maines Residential Design and Mainescraft Construction. Welcome, Mike. Tell us a little bit about yourself and how BS and Beer got started.
Hi. Yeah. So I lived in Portland for 10 or 12 years, and we had a building science discussion group down there that was really popular. It was where the Pretty Good House concept was born. And then when my wife and I decided to move up here to the country, I didn't really know anyone. There was nothing like, there were no discussion groups around. So it was a way to sort of build my own network and to share everything I'd learned about building science and to learn from others' best practices. For a few years, I was trying to think, like, where could we have an event or something, because I don't have like a meeting space at my house. The one in Portland is at a building products retailer. And then I realized that there was a really good local brewery had opened up recently. And so the name BS and Beer just kind of popped into my head. So BS for building science, of course.
I think it's great. I love it. Catchy.
Yeah. So once a month, I come up with a topic and I introduce the topic, and we bat the idea around for an hour or so and have a couple of local brews or not, and chat a little before and after. So I've been doing it just about a year now, and we have anywhere from 10 to 25 people each month, which is pretty good since we're kind of in the middle of nowhere, Maine.
Yeah, but I think it's kind of great that there's something outside of Portland too for all of us that aren't in the Portland area. So I'm a little bit closer to BS and Beer than I am to the Portland discussion group, but I think it's kind of nice to have something in multiple locations.
Yeah, no, it's been fun, and so topics range. I mean, I tend to be a building envelope guy, so I'm always trying to think of topics that aren't building envelopes. So we've done range hood venting and heating systems for high performance homes, and we've done various how to keep your foundation dry. This last one we did exterior insulation, so that's shorthand, as you know, for continuous exterior insulation. One way to insulate a house beyond code minimum. Well, technically it is in the current building code, but most places haven't adopted it yet.
Yeah, I think it was interesting to see that discussion in our high performance building group about the places in the country where exterior insulation is part of the code and where they've struck it out so that people don't have to do it. And then you kind of look at Maine and you see, I think we're still IEC 2009, and that's only in certain towns that have adopted it so far. So
right, yeah, it's kind of like the coldest states, it's not required to have exterior insulation, but sort of in the more moderate states, they have adopted it.
Yeah, I know, it seems kind of backwards.
Yeah, I mean, it is a little, it's different from the way we've been building since 1950, and anything that is different just takes a while to get I think ingrained. And that was another part of the reason to start BS and Beer, was to try to start normalizing these techniques that you and I think are normal.
Yeah,
but that a lot of builders that are just new and different for other builders. My go-to assembly, I think yours too, is a double stud assembly.
Yep.
When certain things align, when it's a new house and you have good cellulose installers and you have a builder who's on board, I think it's a pretty efficient method. Hypothetically, theoretically, according to WUFI hydrothermal modeling, it's supposed to be a risky assembly because in a thick assembly like that, the sheathing accumulates moisture over the course of the winter, and so sort of late winter, early spring, when you don't have a strong vapor drive, you have kind of damp sheathing sitting there. So there are ways to mitigate that, and nobody's ever found, as far as we can know, as far as I know, nobody's found real serious issues with a double stud assembly. But all that aside, just it's good building science, and it works better. It seems to work better with a lot of builders to wrap, to basically frame a house like normal and then wrap it with something. If you meet certain criteria, it means it's a little bit more of a normal order of operations.
Yeah.
And an advantage is having that insulation on the exterior in a heating dominated climate like ours. It keeps your framing warm and dry. Warm and dry basically go together.
Yeah, certainly. And it does, I know a lot of the pushback that we've gotten from our kind of more standard builders, people who haven't built kind of the more energy efficient ways, is, adding the exterior insulation then adds a lot of different joints and techniques that are somewhat new to them. They're used to installing the windows on the exterior sheathing and how that works and how that flashes a window and everything. With our Benson Wood project that we just put up in, it's a Tectonics product through the Benson Wood line. Everybody's familiar with Benson Wood, so sometimes it's easier to just say Benson Wood, but it's not a Benson Wood house. It's a Tectonics house. But they use the exterior continuous insulation, the Styco, which is that wood fiber with the wax impregnated into it. But stuff doesn't stick to that. So that was kind of an interesting, you kind of have to use your own spray glue and spray first the Styco, then to get your sticky membrane to stick to it. So kind of fascinating how those exterior insulations and then, everything is strapped too. So then you have that kind of extra layer of strapping because you can't hang, certain sidings or really any siding probably off of that exterior layer. So
right. Well, that's interesting. So are they putting the WRB on the outside of the Styco, or
no? So the Styco is the WRB.
Oh, okay. Okay.
So it's kind of this 2-in-1, piece.
Yeah.
So the structural wall is on the interior, and so there's sheathing all the way to the inside, and then it's insulated in between, and then it has the R5 Styco on the outside, which is tongue and groove, and then all of that stuff is taped. So it just comes down to the where you're doing your flashings and stuff for your windows and how all that stuff is kind of attached.
Right. So are you, or they making the airtight layer? Is the primary airtight layer at the sheathing then, or are you doing it on the interior, or both?
The primary airtight layer is really at the sheathing, so that's all taped as well. Okay. So I think because the Styco is kind of taped itself and has the the tongue and groove, it's kind of like a double. You get that, but the materials are somewhat vapor permeable, in a certain direction, and so you still have the drying in the directions that you want it to, in theory, in hopes, right?
right, yeah. No, I mean, of course, the most common exterior insulation is foam, usually polyiso. I've done that a few times. I try to avoid foam because of the high global warming potential, big carbon footprint, but it's time tested. It's probably the least expensive and easiest way to get good performance.
Sure. And then you have a really solid vapor barrier all the way at the exterior, which is kind of counterintuitive to building science in cold climates. And I don't know if that came up at all during the discussion group, as we've had that conversation sometimes before, and I have to remind the clients, like, you really can't use any kind of glossy paint or anything on the inside, because we really need this assembly to dry to the inside if we're going to do that, and it runs into its own risks. Have you run into that?
Oh, well, or I mean, I have, I guess I haven't run into problems, but I contribute a lot to Green Building Advisor and their Q&A, and this kind of question comes up there a lot.
Yeah.
And basically what I've learned and try to repeat to people is that the building code, the IRC actually provides some guidance, but you have to kind of understand what's going on behind the actual verbiage of the code. So this, because if you just follow code minimum, U values, R values for our climate zone, zone 6, they would say that it's fine to have a 2x6 wall with R5 exterior insulation, no matter what the insulation is. But
Right.
you and I know that's bad. That means that the wall will gradually, moisture will diffuse into the wall, and then it'll hit a condensing surface, which is, as the vapor moves outward, the first surface that vapor can't continue passing through will be impermeable, and then it will build up basically at the sheathing layer. If you look at Chapter 7 of the IRC, under wall coverings, it's kind of a funny place. You would think wall coverings are like, wallpaper or something.
Like, exactly.
Yeah, but in there, basically, they say that in a cold climate like ours, on the interior, you have to have a class 1 or 2 vapor retarder, which is, anything from traditional poly to the new variable permeance or smart membranes.
Sure.
But that you can do but that if you have a certain amount of exterior insulation, then you can go down to a class 3 interior vapor retarder, which is basically latex paint on drywall. And so what's going on behind the code is, and there's a footnote in there that explains it a little bit, but essentially basically according to the code in our zone, if you have about 32% of your total wall R value on the exterior, that keeps it, and it doesn't matter if you're going code minimum or R40 or R60 walls. It's the proportion that's important. So about 32% on the exterior keeps the condensing surface above 45 degrees 99% of the time in cold weather, which they're saying is enough to prevent enough moisture accumulation to cause problems. They have a similar thing for roofs, but in our zone, it's 51% of the R value on the exterior for roofs if you want an unvented assembly.
Mm-hmm.
And so that's if the exterior is impermeable. But so then a great thing, I've also done mineral wool on the exterior. So it's a bit of a pain to install. It's a little bit trickier to install, but it's like the Styco wood fiber insulation that is vapor permeable. So if you don't quite hit those magic R value numbers, or if you don't trust those magic R value numbers, then you can be rest assured that the wall will continue to dry to the exterior, just like it does on every code minimum 2x6 house.
Yeah. No, I had this great dew point calculator that I used to give to my building science kids, where you could kind of put the inputs. This is a crazy little Excel spreadsheet, but it shows you graphically, because as architects we like graphic things.
Pictures are good.
But you kind of put the inputs in it, and you tell it what your worst case delta T is going to be between interior temperature and outside temperature, and then it will tell you where that R value needs to be, kind of in the wall, for where the dew point is in your wall assembly. Mm-hmm. It's not super slick, so it's a little bit kind of like a check and balance, I would say, more so than like, oh yeah, this is a hard, fast number. Like 11 inches is exactly where it needs to be. Obviously not 11 inches if you're building an 11-inch wall.
Right.
But yeah, so kind of fascinating on figuring out where that dew point is and how that works in the assembly. So.
Yeah.
But I was going to say, were there other things that came up in the discussion that you touched on, or other ways that people were doing it, or issues that they came in, into effect?
Well, I guess the only other assembly that did come up was Chris Corson was there, who owns EcoCore, where I used to work, and they have an there are various names. Most people in the high performance world know it as a Larson truss type system or an outrigger system, where you basically build a structural wall and then you screw eye joists or homemade Larson trusses to the exterior and then spack it on the exterior, and that just gives, and there's enough on the exterior that then you can just leave the service cavity. The structural wall can just remain uninsulated as a service cavity, or insulated if you want to. That's sort of leapfrogging every other assembly to, it's kind of not apples to apples. So we touched on it briefly, but sort of in the assemblies that would work for everybody, I think we stuck with foam, mineral wool, wood fiber insulation. Oh, well, and then zip R. So one of the one of the complaints about exterior insulation of any sort is that it's extra steps, extra labor. So Huber came out with a product called Zip R, and Hunter Panel has their version as well, which is basically a thin nail base insulation. So it's polyiso pre-adhered to OSB, and you actually install it like you would normal structural sheathing, except the foam goes between the studs and the sheathing. And actually, one of our regular attendees, Jim Bahush, has been doing the same thing, sort of his homemade version of studs, then foam, then sheathing. So it's a little bit opposite what most of us do. All the same dew point calculations come into effect. And there are a lot of people have structural concerns with the Zip R, because then you're asking nails going through foam.
I was gonna say, yeah, that's the one comment that I've gotten, is you essentially you have to put your diagonal bracing and everything else in your structural wall and assume that your structural sheathing is maybe not necessarily structural sheathing, which is kind of counterintuitive to how a lot of people here build. The other issue that we came into, I have another builder friend who's built a couple of Energy Star houses, and this was one of the ways that you could meet Energy Star was continuous insulation. And so they used this, and they found that unless you were there and really paying attention to the installer, they would compress it a lot, and so then you would have kind of these different levels between, each piece that, it would be too compressed or not compressed enough, and then you let it out, but then it's compressed, and now you have an air pocket kind of in between. And so it's this, I don't want to say it's a guessing game, but it's definitely one where you have to take a longer period of time to make sure that everything's installed correctly, which is always the feedback that we get, is that I don't want to do anything that's going to take a lot extra time. But I'm sure that you find in the same cases, that first one is going to take extra time. But then once you learn how to do it, you kind of come up with a rhythm to figure it out. So
exactly.
But
Yeah, no, and then we did have a product rep there from a thermal buck. So another complaint with any of these exterior insulation systems is, what do you do with the windows?
Yeah.
Most builders are familiar and comfortable with flange-based window installations. Of course, in Passive House world, we have a bunch of other more complicated ways to install windows. But the sort of straightforward way that's not rocking the boat too much is install the window with flanges. Of course, and so if you're putting it on the sheathing like you normally would, and then like you said, if you add exterior insulation beyond that, what do you do? Or do you one conventional approach is to run a 2x4 buck, we call it, around the window opening, around the rough opening to push the window out, but then you have this big thermal bridge. You're doing exterior insulation to improve thermal efficiency, but then you're creating this big thermal bridge around the window. Or you leave the window inset against the sheathing, and you have to make up exterior extension jams. That tends to be my approach, because I like the extra shadow lines, but it's extra work and some funky flashing. So this company, Thermal Buck, basically makes a high density foam buck. Really, it's sort of an offset L shape that you run around the rough opening. It's dense enough to hold the window out in the plane where you need it to, so it planes in with your siding and trim. It's dense enough to not compress significantly when you nail it, but you do have to get your fasteners all the way back to structure. It's not a structural buck. It's really just a thermally broken spacer, but it seems like it fills a pretty good niche.
No, okay. Yeah, that would be really interesting. I don't know that I've ever seen their product before. So, especially if it's something that, seems kind of, not that it's normal, but it seems kind of standard for somebody to figure out how to use. We actually just got, so we're doing the level project, and our windows went in the factory before it ever, came to us. And so our walls went up in January, and then we actually fabricated all of our pans and everything for the house, because we didn't have any. So we just assumed we weren't getting any. And then, last week a shipment showed up, and they were all written in German. And luckily the guy that had, put them in has built other projects with these windows that were coming from Wasco, which were coming from, Europe, obviously. And so they had sort of figured it out, but he had already fabricated something, so we didn't end up needing them. But what do you do when something shows up on the job site and it's totally written in German, and you have this kind of unusual window situation, which wouldn't be standard, because ours are obviously, set in the center of the insulation. They're inset, they're completely different than, what you would consider standard construction, flange window. And so it's like, I don't read German.
Yeah, I think that's a problem across the board in high performance construction. Is all this stuff is pretty much normal in Europe, but it's usually written in languages that aren't easy for us to read. It has to be imported from there. So if something goes wrong, you have to wait 14 weeks for a replacement. And there's, if you want the ultimate high performance, if you want to see what we should be doing, then that's where to look. But yeah, it can be tough to find. Well, I think the Americans, North America, the product lines available made in North America are growing, which segues into the other thing that came out of our discussion was, for the wood fiber insulation, there's Styco you mentioned, there's Gutex, which is imported from 475 in Brooklyn, and then there's one other. Agapan used to be available here, but I don't believe it is anymore. There's a company in Canada bringing in Ecotherm, I think it's called, that's more like a semi-insulating structural sheathing. But anyway, there's a Maine-based company, GoLab, which is related to their design build firm Geologic, and they are working on and getting pretty close to starting production of wood fiber insulation. Most likely based in Maine. So most likely getting an old Maine mill that's been shut down, get it up and running, use relatively low quality wood pulp and press it, and mostly with the natural lignins in the wood as a glue, as a binder, add some paraffin wax and some food grade preservative, and you have a very low carbon footprint, high performance, vapor open, locally made insulation material. So it's pretty exciting.
I think that's fascinating, and I'm glad that they're finally getting up and running on it. I know I spoke with Ted Benson yesterday, and we were talking about a lot of things. He wasn't sure. He knew they had some funding or a grant to kind of get this started here, and that would be great for them, obviously, too, not having to buy something that's coming from across the ocean. And also a couple of contractors kind of local in this area that were like, it would be great if this was happening here. And so I think there are a couple of people who are really pushing it, and hopefully the high performance building industry here in Maine is going to kind of pick up on that, and everybody's going to start using it. I know it would be pretty fascinating. It might change how we build our double wall construction too. Our walls for the Lovell house are a 2x3 structural wall. That's our chase on the inside, and then we have sheathing, and then we have a 2x6 wall, I think, on the outside that's dense packed, and then we have the Styco, which is an 1.5 inches, I think, thick on the outside. And so as far as panelization and the future of panelization, that's maybe just as easy for somebody to kind of figure out as, maybe a little bit more so than, Chris Corson's, which is, fabulous that he has these great eye joists that are, super thick and hang off the structural wall. And, those houses probably lose heat for a week and it's still just as warm on the inside.
Pretty much, really. It's the best way it's the best built house in the world, I think, but not everybody can afford the absolute best. And even Chris is actually looking at, or may actually be working on a project where he's actually looking at panelizing with wood fiber insulation, and I know a couple of other builders who are diehard foam free builders. They really like double stud, but they've said, and they've tried out wood fiber insulation and say if it's made here, then they'll most likely switch. It's easier to work with than rigid foam. They say definitely easier to work with than rigid mineral wool, which isn't really rigid.
Right, it's kind of an interesting texture. I've seen it, and someone wanted to use it in basement insulation, and I was like, I don't know exactly about this. Yeah. I've never personally used it as an exterior continuous insulation. So
Yeah, no, well, and it's safe enough. You can also use it on the interior, and dense enough you can plaster it right over it. Apparently, so
Oh,
that's kind of an interesting
yeah,
approach. I might actually try that in my old house. Just put it
just
on
to
the
test
walls
it
and
out. Yeah.
put some American clay over it and call it good.
Right. So.
It was I'm sorry, I had something, but it escaped me.
Oh, no, that's okay. It happens all the time, right? You're thinking something, you're going, I'm going to remember that. And, or, we built or we bought an old house here, and I keep thinking, well, what can I do to change that and continuous insulation, and what, the siding needs to come off, and it's a sort of never ending project.
Yeah.
So, but it's fun. So,
Or I know what it was. If you don't mind a quick shameless plug, one of my
no,
other,
go
in
ahead.
addition to designing and building and a little bit of farming, I also am a contributing editor and have a column for Fine Home Building magazine.
Fantastic.
So every month I write about high performance and or low carbon things, building related things. And so I'm working on right now. My next piece will be on wood fiber insulation. So sort of an overview of these products we're talking about and some more of their characteristics and
Yeah.
where to get them and what their R values are and that.
Yeah, no, I think that's fantastic. So people can find your articles and find home building. You often comment, you have a column on Green Building Advisor, or
It's not a column. They occasionally because Fine Home Building essentially owns Green Building Advisor. Sometimes they'll take things I write and publish them there. But I also just like hanging out at Green Building Advisor. I learn more than I contribute. But when I can answer a question, I try to.
yeah, me too. I got their email today, and I'm reading through all the stories that are on the email that got sent out today. Like, oh, okay, what have I missed, and what do I need to see? And as a building science junkie, I guess you could say, you can really spend a lot of time kind of just learning, and it's fascinating being able to share with other people and see what other people have done, because that hopefully will only make us all better, builders and architects.
Exactly. No, for sure.
But was there anything else that came up during the building science discussion, or is that kind of hitting the highlights?
I think that was the highlights. I'm trying to think. I guess the only other thing, just I had some notes as part of my introduction, and we ended up talking about it a little bit. You and I talked about it a little bit, but just the basic concept to take a step back is that the Joe Steberg Building Science Corp perfect wall assembly is kind of what we're talking about more or less, and then also just the idea of dedicated control layers. And so putting the insulation on the outside uh, is a good place for your thermal boundary, and then just where do your air barrier, your vapor retarder, and your rain barrier fall in between there. So depending on what the exterior insulation is, the arrangement of layers may change a little bit.
Sure. Yeah. And I know as an architect, we've been playing with the idea of issuing our drawing sets that in color, and having, each of those layers color coordinated. Sort of when you take the passive house training, they give that really great diagram of, the blue layer is the water, the WRB, and the red layer is your thermal barrier or your air barrier. I'm going to get them all the colors wrong. But anyway, it's very clear in them, even if it's diagrammatically, like this is the path of how all of these things should go together and how they should be connected. And I think that that's something that's maybe a little bit missing too in, drawing sets that we give out is, here are all the parts and pieces. We had a fireplace installer, and this wasn't on one of our projects, but it was a fireplace installer that we work with. And they went in to fix an issue because somebody had built a really efficient house. It was a really tight house. And then the previous installer had come in and just sort of blown a hole through everything to put the chimney out through. And it rained inside the house, and they, couldn't figure out why it was raining in the house. And so, always really fascinating how, something really small or really simple in these high performance houses can have such a major impact. So like we got into, the details, which I hope this podcast is going to continue to do, is, talk, macro and micro scale of things, the dew points in the walls, things that people probably haven't thought about or talked about before, but that, us in the building science industry is something that we have to think about. And, how do we translate that, me as an architect to a builder who hasn't done it before, and you as the, builder designer to, subcontractors who are on your site who are helping you kind of pull all the details together. So kind of fascinating discussion, but I'm going to wrap it up here because I think that the podcast hopefully is only going to be about half an hour long, which is a wrap up on, building science discussion. But I'd love to have you back. Hopefully we can keep up with after BS and beer recaps and all of that. But, you're one of my building science buddies here in Maine. So I hope that if you're willing to, you'll be on the podcast. Lots coming up, plenty of things to talk about.
I'm sorry.
I said plenty of things to talk about.
Yes, no, for sure. No, I think it's great that you're doing this. I'm honored to be your first guest, and yeah, let's keep it up.
Yeah, absolutely. I think it's going to be great. So thanks, Mike, for joining us today. Again, this is E3 Podcast, Energy and Efficiency with Emily. So hopefully we'll keep talking about insulation here in the month of April and see what happens.